So right now we're gonna try to do is, I reckon some of you guys have had issues with the keyboard layout. That is, some of the keys are not working properly. Is that something you've been dealing with? Yeah. Yep. All right. So we're gonna change the keyboard layout inside your Ubuntu machine, or inside your BioLinux machine, so that it all works smoothly. Because you can find or guess which is which, but it's better if you have the native keyboard working properly. All right. So the solution is kind of simple. Yep. So you'll go to settings here on the left panel. There's one that says System Settings. Then you go to Text Entry. Sorry. Here. Can you guys see it in the back? Or we should zoom in. Are you guys following in the back? Oh, she left. All right. Yep. So if you have problem listening to me or looking at the screen, please let me know. Yeah, here you'll see only two options, usually, English US or English UK. Yeah, you will go here to the plus sign on the bottom left side of the panel. There should be a plus sign. Just click it, and you'll be given a lot of options. Just look for Spanish and check if you have the ñ, yeah, the N with the. Just look for your own default keyboard, your keyboard configuration. Most of us will have the Spanish Latin American keyboard. Some of you may have the European the European English, European French, or Belgian. So you just select the one that fits the best for you. If you're not sure, yeah, just for example here we've already added the Spanish Latin American. You put it as first, and then on the white panel you will see on the bottom right you will see a small icon with the shape of a keyboard. Just click it, and it will give you all the keys that you're supposed to have. If you push one of the keys, yeah, you should see it blinking on your screen. For example, if I push 1, it will detect it. 2, 3, 4, 5. Q. If I want to test any of these, for example, brackets, close brackets, dash, 7. So I know this is the configuration, the right configuration for me. There is even an ñ there that I can push. So I know this is the right configuration for my keyboard, right? Please make sure that you have the right configuration for your keyboards as well, so that we don't have any issues with trying to type or trying to write things and we cannot find the right button. Good? Yes? So let's just continue for the time being. Unfortunately, there is no easy fix for the laptops that are having trouble with the current virtual machine. If you find that your computers are being a bit slow, make sure that you don't have any other virtual machines open at the same time. Sometimes we do that. We open several of them at the same time. So just make sure that you have only one virtual machine open. So yeah, in the previous session, we were just playing around with where we are, right? Right now, what we need to do is we need to import some data. For that, everybody should have run the extensions for the Oracle VirtualBox. If you see on the top menu, there is one that says Devices, or in Spanish it would be, yep, Dispositivos. Yeah, and Shared Folders, or Folder Compartido, and Shared Folder Settings, or Configuración de Folder Compartido. Right now, it's going to be empty. Yeah, we want to add one directory. So what we're going to do is we're going to push. Can you guys see this, or do you need a zoom in? In the back, do you guys can see this? Yes, no problem. Can you see what I'm pushing? Yeah, and we're going to configure a sharing directory between your Windows. You don't have to do it because you already have Linux. So between your Linux host operating system and the virtual machine. This is going to be important when you want to download something in Windows and then you want to use it on your Linux machine. So first you select a folder path and then on otros, and click there. We're going to go to Documents. Yeah, go to Documentos, and create a new directory. How's it going? All right, so INEA shared. Okay, just double click that one, accept, select folder. Yeah, and then this is you have to remember this folder name, INEA shared, just that little name, INEA shared. Now we're gonna call it, we're gonna mount it somewhere. Yeah, what does it mean mount it somewhere? We're gonna create a directory out of the blue, whatever you want. I will give you a recommendation, but you can choose whichever you want. Yeah, where all the files that are present in that directory in Windows, you are gonna be able to see them in Linux. I'm gonna call it in Home Manager. If you remember, inside, can you guys see, or you need it bigger? Can you guys see what I just wrote there in the back, or is it a bit? So we're working on. Can I use that? So remember, it's /home /manager /documents capital INIA -shared with capital S. So you guys put it there. Oh, one thing that I forgot to tell you during the first part. Yeah. Avoid spaces. In Linux, avoid spaces as much as possible in the names. Linux is going to read a space and it's going to think it's a different word. Well, it is a different word, but it's going to think it's a different command altogether. It's not going to recognize that a directory or a file with a space in the middle, yeah, it's going to be a single file. For example, if you put INEA espacio shared or INEA espacio compartido, yeah, Ubuntu is going to think that INEA and compartido are two different files. Yeah, so avoid spaces at all costs. If you have to use spaces, yeah, usually you will have to escape them in order to use them, and that requires you to use backslash and other tricks just to make sure you're able to use them. So I would recommend you just avoid them altogether. Is all going to work? Yeah. Oh, all right. Let me touch that. So if you guys don't have this mount point, don't worry about it. Just select this one. You just put the default there. You don't need to put auto mount or read only. You can make it permanent if you want, but not necessarily. It's up to you, really. There is no big difference between the different way to mount it. But if you don't have this mount point, don't worry. Leave it blank and just accept it. Just put OK. Why do we leave it empty anyway? Because what we're going to do in the next step is remount it. We're going to create that directory, the one that I just showed there, INEA shared, inside Documents, inside Manager, inside Home. Yeah, and we're going to remount the whole thing, that directory in Windows, into our Linux distribution. Don't worry. Now you only have one shared directory. If you have more than one, that means that you have shared more than one directory. Just check that, because if you try to add one more and one more, or more than one shared directory to a different mount point, it's going to break. You're not going to have the option of putting accept or OK. You're not going to have that option. Right now I only have one. We should all have only one shared directory. So you remember this directory where we mounted it, right? Home, Manager, Documents, INEA shared. So you would expect that if you go to that location, it is already there. That's what you would expect. But things are not so simple usually here in virtual machines. So let's first check where we are. We're on Home Manager. Let's move to Documents. Yeah, and let's see what we have inside Documents. So that directory that we kind of created right now, where the mounting point doesn't exist. Since it doesn't exist, we should create it. So in order to create a new directory, you use the following command: mkdir, mkdir. And then after that, you put a space and you put the name of the directory you want. In this case, it would be INEA shared. So is everybody with me at this? mkdir space INEA shared, INEA-shared. Yes, you cannot see it from here. It's a bit blurred, right? Be careful, guys, and look at the reply of the. For example, that's a good example of a standard error. That's the error that replies when you try to run one command, but there is an incorrect argument or something. I'm going to show you something. So if you're not aware of your capitalization, yeah, and Linux is sensitive to capitalization, yeah, you're going to run into problems like this one. So I'll go back. Yeah, I'll show you. I'm on Home Manager, and then I can see that I have documents. But I try to write this documents with a lowercase d. The command cd is telling me there is an error. I don't know if you can read it, but it says here, cd period, no such file or directory, period, documents. Why? Because I'm using lowercase d. Yeah. If we use the incorrect, this is telling us the command didn't work properly. There was an error. So that means that you haven't moved, you haven't changed directory as you wanted to. Yeah, you have to be careful with your capitalization, the way you write things. That's why we usually recommend using the autocomplete. Just write the first few characters of the file or directory you want to use and tap. And the computer, or the shell, it's automatically going to complete whatever you wanted to write. For example, you start capital DOC and then tap, and it's going to autocomplete whatever you want. Are we going? Yeah, once you create your INEA shared, please just cd, change directory into the INEA shared folder that you just created. All good? So everybody is inside the INEA shared directory. I'm going to try to increase the size of the... Hey guys, is this size of the fonts better? Can you look at this better? It looks better? So please look at the last line in the screen. Yeah, that's the command we're all gonna put. That's the mount command. Mount command lets you, as the name says, mount an external drive or whatever accessory device into your Linux distribution, your Linux file system. And you're gonna create a directory that, well, we're gonna use the directory that we recently created, INEA shared, yeah, as the mount point. So whenever we cd now, right now, if you go into cd before the mount, you'll see that it is empty. Even if you have any documents on your documents INEA shared directory on Windows, you cannot see them on Linux. Yeah, this command will let you take a look at that. Now, please be careful that you use, when you created that shared directory, the shared directory has this name, INEA shared, with a dash. If it doesn't have the dash, it doesn't matter. Just be sure that the command line fits with what you wrote before. Yeah, it has to be a perfect match between what you wrote before and what you're putting in this command line now. Right? Mount. Only root can do that. By root, they mean you need administration. You need to run it as administration. And in Linux, there's a very simple way to do it. Usually, we'll ask you for a password. The password here is going to be manager. Yeah, but what we do is, before that, before all this command, before this command, you're going to put the following keyword. It's called sudo. S-U-D-O. SUDO means super user do, basically, which is, okay, I'm the super user, I'm the administrator of this machine, and I want to do this, so I have all the privileges. When you run this, it's going to tell you password. Your password is manager. You're not going to be able to see it, but it is manager. The same one as your username. So I don't know if you guys copied, I hope you did, these three files here, sequence.gff3 and sequence2. On Windows, please go to your INEA shared folder and just, so after doing that, if you still cannot see your the contents from your Linux machine, please just close your command line. Just type exit on your command line. Can you please check the, oh, yeah. So when you go to Windows, copy the files sequence2 and sequence.gff3. Go all the way to CD manager, no, CD home manager documents. Oh, you didn't download them? Does everybody has those three sequences that you can see there? It's sequence.fasta, sequence.fasta, sequence2.fasta, and sequence.gff3. If you guys don't have it, just let me know. We have the USB sticks. We can just pass it around. They are very small sequences. These are 2 chloroplast genomes and just an annotation table.
Basically, the code is the same one as your username, which is manager.
Okay, guys, please remember the following. If you're having issue with the password is manager, just like your username. M-A-N-A-G-E-R. Manager. When you do sudo anything and they ask you for a password, even though you don't see it, you just type. So for all of you who have already been able to see the different files in your shared directory, good on you, congratulations. You're one step closer to starting to look at it. Now, as you can see, this is not a very useful look, right? You'll see a lot of, the first part of this display is just permissions, yeah? Here it tells you, it has 3 spaces. First is the owner, the permissions that the owner have. The second group is gonna be the group. Yeah, if you belong to a group in the Unix system, you can define the groups, or administrator can define groups. Then the group, all the people from that group will have these privileges. Yeah, and the third space, or the last 3 letters mean the access that have third-party persons, people who don't know you, you've never talked to, you don't know who they are, what they work for, who they work for. Yeah, they have all these permissions on your files. Obviously, we don't want people who we don't know to be able to access all your files. Now, you'll see there's a 3 code letter here. I don't know if you can follow it. RWX. RWX stands for read, write, and execute. So that means when you look at the first 3 letters that says -RWX, that means that the owner, which is you, yeah, has reading, writing, and executing permissions. If this was if this were a program or a binary, an executable, you should be able to execute it. These are not. If you want to modify something, like for example, you want to open it and see the entire content, you can, because you have reading permissions. If you want to copy this file from this directory to a different directory, you can, because you have reading permissions. If you want to go into the file and modify things inside the file, you can, because you have writing permissions. If you want to remove, delete this file from your system, you can, because you have writing permissions. So you can see how if somebody else besides you has the same permissions, it could all get a little bit tricky. Yeah, you don't want any random person to accidentally remove, erase, modify, or just corrupt one of the files you've been working so hard on. So we need to make sure that not everybody has the same permissions. Now, I want you to remember these 3 numbers. 1, 3, and 5. Why 1, 3, and 5? This comes from the binary code, but basically is, if you have 3 spots, yeah, 3 spots in the binary code, the first one, if you have a 1 on the first spot, it translates into a 1. So a 001 means 1. If you put a 1 in the second part, a 010, I'll just put it here. So a 001 in binary means 1 in decimal. A 010 and a 100 means 5. This is the way we translate from binary to decimal, right? 001 is 1, 010 is 3, and 100 is 5. What does this mean? The first part here is the execution permissions. So if you have this turned on, this 1 turned on, this means that whoever has that value has execution permissions on your file. The second one, this 1 here, the second position means writing permissions. So if you enable that to other people, you enable this 1, which will translate into a 3, yeah? That means you're giving them writing permissions. If you access the last one, which is 100, the last position, that means you're giving them reading permissions. More often than not, we can allow people to have reading permissions on our things, it doesn't matter if they see what we're doing. Yeah, it does matter if they change it. So we want to remove the execution and the writing permission from our files. So what do? There are many ways, but look at all the combinations you can get from here. If you want to give only execution permissions to somebody, it would be 100, right? Because you want to give him execution permissions, you don't want to give him writing permissions, and you don't want to give it reading permissions. So it will be 1 plus 0 plus 0 would be 1. If you want to give them execution plus writing permissions, it would be 1 plus 3 plus 0, it would be 4. If you want to give them just execution and reading permissions, what do you think it would be? What would be the number? Just execution and reading. We don't want to give them this one. It would be 6. Well done. Yeah, if we want to give them all of the permissions, it would be 7. Oh, shit. Yeah, no, this is my error. Sorry. This is 2. And this is 3. Sorry. Now it makes more sense. Sorry. Now, if you want to give them all full permissions, it would be 7. If you want to give them execution and reading permission, it would be 5. If you want to give them execution and writing permissions, it would be 3. So let's take a look. Let's say that I want to only give all permissions to myself and no permissions to anybody else. So what we do, we use the chmod command. chmod, it's to change permissions to people. The first number, as I mentioned before, is going to be for yourself. So for yourself, let's give us full permissions. That will be 1 plus 2 plus 4, 7. Now, for our group, the group of people we usually work with, yeah? For now, let's say we don't want to give them any permissions. Nobody can touch what I'm working on because I don't have a group. I work alone. Yeah? So let's give them 0. And for anybody else outside of my group, people that don't know that I don't know how they got access to my computer, we also give them 0. Yeah, and since I want to apply this to all of the files, we will use the asterisk. The asterisk is a wildcard that says all of the files here, they will all be modified with this command. You do the ls. ls command is to list the contents of a directory, and I've added an extra -l. The -l is to show more details. These details of permissions, owners, groups, size, date of generation, etc. The green color, that's a default. I really don't know how to do that. No, not even with sudo. So yeah, we're gonna have a problem here. The commands work. The only problem is that we don't have ownership of the files because it comes from Windows. So let's play a game. What we're gonna do is we're gonna create a new file. How we're gonna do that? We're gonna concatenate the 2 sequence FASTA files into one new file. For that, let's first explore what's inside each of these sequence files. So we're gonna use the command head. Are we all there? We're going to use the command head, H-E-A-D. And now pick any of the files that you want. I would recommend going for the FASTA, but please just write that command down so that you can see the head of your file. Now, you can do the same with the tail. Hay que pedirle al dueño. ¿Qué tal te va? ¿Sí? So, guys, this is an important way, an easy way to actually take a look at what the contents of your files are. If you would like to take a look at the whole file, just try the command cat, C-A-T, and the name of the file. You're going to see that you cannot process it only by sight. You're going to see that the file, even though it's only a chloroplast genome, it's way too long to actually do anything with your eyes. You need to find a way to systematize the way we look at this file. That's why we start looking with things, with commands as simple as head. We can also use tail to just see the end of the file. Just as we used head before, we can also use tail. Tail will show you the last 10 lines of any file. If you see here, if you count it, you'll see 1, 2, 3, 4, 5, 6, 7, 8, 9, and a space. This space is a new line, an empty line inside the file. Linux is not going to make any difference between full lines or empty lines. It's just going to show you the last 10 lines. If you have 10 empty lines at the end of your file, it's going to show you 10 empty lines in your file. Now, you can tell these commands how many lines you want it to show. The only thing you need to add is a small flag. It's a small flag called -n. So in the same way we did here, we just add -n5, and that we're telling just show me the last 5 lines. Now let's assume we want to do something more challenging. We don't want just the first 10 lines. What we want is the last line of the first 10 lines. That is the 10th line. Only the 10th line. This is where piping comes into play. Piping is the art of using this symbol here. Can you see it on the screen? Just a vertical line. That's a pipe. That is going to join 2 different commands, one after the other. For example, let's put this example that I just said is we're going to display only line number 10. Only that one. So we can start thinking something like, okay, let's display the first 10. Head -n10 sequence.fasta, right? And it shows us the first 10. But I say, okay, from that little snippet, from that little file, how many lines from the bottom we want to see? Yeah, if we wanted to see only the 10th line, the line number 10, how many lines from the bottom we would have to pick? Just one. Here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The last one, that's the one we're looking for, right? So what we do is we do the same, but instead of pushing an enter here, we add a pipe. This pipe is going to tell it, okay, this is the input for a new program. And what is the new program? What is the new command we're going to tell it? We're going to tell it to tail. Tail -n1. Why -n1? You only want the last line. Are you guys all following me all the way here? Now, compare this last part, the tail -n1, to the previous tail that we used. After the tail -n5, we put the name of a file. In this case, we don't, because the file we're using is whatever the output from head was. So, since this was the output from head, this is going to be like the temporary file that is going to go into the command tail. Yeah? So let's push it, and you'll see you only get one line. And if you just want to check, you'll see that it's exactly the same line that is the last line of the head command before. Yes? The pipe? Yes, let me. No problem. So are we all the same? Okay, so let's just ask the next question. Let's say that yes, we want to see this last line, but we want to do something else. We want to count how many characters this line has. Because I could count it with my fingers and start 5, 10, something like that, maybe 60 or 50 or something. But let's do it more systematically. So we have another interesting command. It's called word count, WC. Yep. So what we're going to do is we're going to add one more step. So we add another pipe, and we add the command WC. WC is word count. I'm going to show you in a second how you can see all the options that each of these commands have, because they have a lot of options. Yeah. But in this case, for word count, we're going to use the option -C. -C stands for characters. That is word count, but not just words count. No, I don't want to count how many words there are. I want to count how many characters there are. Yeah? And on what? On the output of the previous command. So the first command gave me the first 10 lines. The second command gave me the last line of those first 10 lines. And the third command is going to count how many characters that single line has. We put enter, and you'll see that you get a number. Did you all guys get a number? Now, if you wanted to corroborate and start counting by yourself, you'll see that we actually have only 70 characters, not 71. Why does it show 71? Because at the end of each line, there is always a carriage return, what we call a new line. It's an invisible marker, yeah, but all the systems have it. Every time you press an enter on a text, whether it's on Windows, on Notepad, on whatever you're using, the program knows that you've entered a new character. That character, called the new line, is invisible. We don't see it, but it is there. And that's why this is counting it. This is counting the characters. So let's say you want to do something out of the ordinary, and you don't know how many different flags or options a command has. All right? For example, head. We know that head will show the first part of a file, but we don't know how many options you have. So we have man. This means manual. Man stands for manual. So we want to see the manual of what command? The command head. And you'll get this scroll down help menu, if you wish. This scroll down manual. And it will tell you all the possible options that you have to use this one. For example, -c bytes. It's going to ask you how many bytes from the start of the file you want to display. So not only can you just tell them, oh, display this many lines, you can tell them, no, display this many bytes. Take into consideration that each byte is more or less one character. Then -n, the one we use, number of lines. We'll say, okay, display only -n 5 lines, -n 10 lines, -n 100 lines. Quiet means never print headers. This is usually useful when you're doing the head of several files at the same time. Yeah, I'm going to show you this in a second. Verbose, you wanted to give you as much information as possible. Most of these commands have more or less the same options. Verbose always means show me as much information as you can, a lot of information. Yeah, so you see this is a very small help because it's a very short and concise command. But there are commands that are way more complicated. Look, for example, head. Let's use this. Star.fasta. Star is a wildcard. That means whatever matches. Yeah, it doesn't matter. It can match any character, how many characters we want. So if I say head star.fasta means anything that finishes in .fasta, I want to run the command head on. So if you run this, you'll get two outputs, one after the other. And you'll see the title here. First, it will check on sequence 2.fasta, and it will show you the first 10 lines. Then it will show you the sequence.fasta, which is a different one, and it will show you the first 10 lines. No, this is not BI, this is head. Yep. I'll jump into BI in a second. Just want to be careful that. Now, do you remember that I told you that, that Linux is very secure because you know exactly what's going on in the background of your system all the time? Please type the following command. This command will show you what is currently running on your system. Stop. You're going to see what is running, who is running it, who's the owner, how long it has been running, how many resources it's been using. All of that information is kind of summarized there. Yeah, you have the titles on top, so you know this is the program ID. So this is the way you recognize what's the ID of the program running. This is the user who has launched it. For example, you have Debian, you have manager, you have root, you have www data. These are different users. Root. Well, this is virtual memory. This is CPU usage, how many CPUs you're using for each of these, how much memory in RAM terms you're using, 1.8, 4.8%, which means like maybe a few megs. And you can see what is the command. Using Python. Who's using Python in the background? Why do I have Python in the background? No, doesn't matter. Yeah, so you have all these different programs that are running in the background. Enough to say, suffice to say at this point that all of this is normal things running in the background of an operating system. These are controllers, these are input, output, or I/O requests. These are the shell. These are all the icons that you're seeing and the interactions that you have with the mouse. All these things have to be running on the background. Otherwise, they wouldn't work. All that is the things that the OS needs to do in the background in order for it to work. Yeah, if you want to interrupt it, just type Q, and you will leave, and you will return to your normal shell. Yeah. You do head minus B, if I remember correctly, or minus C. Head minus C 20 sequence dot faster. Something like that, if I remember correctly. Yeah, because that means 20 bytes, which it's more or less the same as 20 characters. So yeah, you see that you have only the name. No, because your file, it's not only the sequence, it has a name and a sequence. The first part of your file tells you the name of the sequence. So when you display the first 20, yeah, and this is something you need to be careful about. It's like you usually have headers. You usually have descriptions of what you've got in your file. Yeah, and if you're not careful enough, when you try to display something like the sequence, you'll end up displaying the name or the description. Then you check where does the sequence start? Does it start on line 2? Yeah. So let's pipe it. Let's say head minus n2. Sorry, minus n2. Sequence dot faster. Yeah. And then this is going to give me, if you remember, it's going to give me the first line, which is the name, and the second line, which is the first line of the sequence, right? If we want to test it, let's test it just to be on the safe side. You'll see the first line is the name with a short description, and the second line is the sequence. Yeah, so what do you want to do? You want to do, but let's break it down into steps. So you got the first 2 lines. Do you want both of them, or do you just want the last one? Yep, so we pipe it. Pipe it to tail minus n1. What is this going to give us? This is going to give us the last line. That is the first line of the sequence. If you want to check it, just run it. Yes? But now you don't want that. You want the first 20 characters. How would you do that? Just remember the first one we tried. Head minus C 20. Minus C is number of bytes. If you remember, if you put man head, you will see that you had an option that says minus C. And it tells you how many bytes you want to display. If you assume that each byte is going to be 1 letter, 1 character, then using minus C 20 will give you the first 20 characters. What will happen if you do that? Remember, if you only put head minus N2, it will give you 2 lines. And if you do head minus C20, it will give you the first 20 bytes of those 2 lines. It's going to be the name again. We can test it. If we remove the tail, that means that we're going to have the first 2 lines, right? The first 2 lines, and then we're going to get the first 20 bytes of those 2 lines. We've got the name again. Now you are kind of understanding the power of piping. Why is it so important, so easy to just do these kind of things? Now, imagine what you could do if you were able to sort on top of that. You want to sort all the lines in a file. sorted alphabetically, sorted by ASCII code, sorted by, I don't know, the length of the sequence. You can do it, yeah? And then you can just get, okay, let's merge all the lines that are exactly the same. There is another command called unique. If you have the same line repeated over and over and over and over and over again, you compress them into a single one and it gives you a count, how many times it was seen. So all this, you can do it so that you can compress, really do complex analysis of what you're doing. Well, not really complex, but really simple analysis of what you're doing of very complex tables and still get a more readable result. You don't have to read over a 20,000 line table or a 6 gigabyte, 60 gigabyte FASTA file with all your small reads that you got from a sequencer outside of Peru. No, you don't have to do that. Yeah, you can just use these tools in a smart way, these piping tools in a smart way, so that you can just compress the information, get all the important metrics, yeah, from your data before actually having to load everything into memory and read it. Now, if we wanted to actually do that, yeah, we're going to use, this is VIM, this is like a text editor for the command line. Just write VIM and any of the files that you, just add any of the files that you have there. Sequence.fasta, sequence2.fasta, sequence.gff3, whatever. I'm going to stick to my sequence.fasta. And you'll see that in contrast to what happened before when we used the command cat, that we had just an endless amount of lines rushing through our screen and we weren't able to read any of them. Yeah, here we can explore a little bit. You just play with your arrows and you just keep going down, down, down. If you want, you can use the forward page, down page also to explore. You will see that at the end, you'll have some numbers. It will tell you the number of the line, or the number of the row, the number of the column you are at, and also what percentage of the file you've already seen. So you see, we've already pressed a lot of down page, and still we are at 20%. There is absolutely no way, well, maybe somebody very dedicated, but it's very time-consuming to actually look at this sequence and try to guess something out of it just by looking at it. Trying to deduce things, where the genes are. Here, this is an actual sequence from what? Solanum tuberosum chloroplast complete genome. This is the complete genome of Solanum tuberosum, potato. At least from the chloroplast genome. Yeah? It has genes. It has useful genes. It has interesting genes. Biologically relevant genes. Genes that could be used for breeding, genes that could be used for genetic engineering, genes that could be used for anything. And yet, from this sequence, the raw sequence, we see it, we can just read it all together. We cannot guess anything, not straight from there. Not with our bare eyes. We need computational tools to actually be able to handle this data, get information from this data. We need to predict genes. We need to annotate genes. And speaking of that, that's something we're going to do later on in this course. But how do you annotate genes? How do you know what parts of the genome have genes? Where do they start? Where do they end? What direction are they in? Okay, all that is already coded. We already have a standard tables, a standard formats to handle that. If you see, you will see that you have a sequence called sequence.gff3. GFF3 is a format, general feature format. Yeah, this is something we're going to see later on, but you can just start taking a look at it. You can also Vim it. You can, by the way, if you want to get out of this one, get out of this editor, just do period Q. And just to be safe, an exclamation mark. This actually says quit, yeah, and just quit without saving anything. I don't want to save any unwanted modifications that I run. Yep, just quit. And if you see, you have a sequence.gff3. If you vim, yeah, you won't tell from the look of it. It's not easy to see, but it's just a table. It's a tabulated table. Between each of the columns, there's a tab. That's how we know what column stands for. And each column has a proper definition of what it is. But basically, it's telling you that here there is a sequence called region 1 that goes from nucleotide 1 to nucleotide 155,296. It's on the positive strand, which means that it's on the one that we're looking at. The ID name is NC00. This is the reference taxon 4113. Is circular, true, which means that it's a circular molecule. It should be understood like that. Name is plastid. Cultivar Desiree, which is one of the varieties of potato. GBK is the source. Genome chloroplast. Molecule type is genomic DNA. And all sort of extra information. The most important parts of this information are the first 8 columns, which give you critical information about where the coding starts, where the coding ends, where the gene starts, where the gene ends. This is a table. We're going to learn how to handle tables easily with command line tools. But you can just explore it like this. You'll see that sometimes you have CDSs, sometimes you have genes, sometimes you have exons. So there are different features that are being named here. Excuse me. And this is the way, the actual way a genomic annotation format works. It is standardized. Everybody uses this. And there are tools that let you read and display this graphically so that you don't have to write them or draw them using paintbrush or using bars in PowerPoint. You can actually display very nice displays of how the genes are located, where are the exons, where are the introns, etc. Yeah, just using this information that you have stored here in this kind of tables. SAMTools is a set of tools that let you manage not only sequences like genome assemblies or also RNA-seq, yes. Not so much RNA-seq because it's FASTQ sequence, mostly just FASTA sequences. But yeah, you could make some things with FASTQ as well. But basically, it lets you do like random accessing of parts of the genome in a very efficient and easy way. You can just tell SAMTools, FedEx, which is the command, the internal command used to display parts of the genome, and you tell them, show me chromosome 1 from position 1 to position 7. And it will show you just those 7 letters, so 7 characters. Yeah? You can have an annotation file in GFF3 format that tells you, oh, all these are the exons. I'll say, okay, just show me all the exons in this annotation file. And it will go look for the coordinates, and it will display you. Okay, exon 1 from chromosome 7, position 1,000,002 to 1,100,000. It shows you the first exon. Exon 2 from position 1,300,000 to position 10 million. Exon 2, and so forth and so forth. And it does it very efficiently. You will see that in the BioLinux distribution that you have. Yeah, if you try to write SAMTools, just TOOLS, yeah, and enter, you'll see it will give you a list of options, which are subcommands inside SAMTools. You can also use the SAMTools space -- help. It will show you a help window. SAMTools, unfortunately, doesn't have a manual as far as I know. But it does, when a program doesn't have a manual, it does have a help. Here, for example, it will tell you program SAMTools version 0.1.19, usage, SAMTools spice, a command, and then options. And then you have a list of all the commands that you have. SAMTools was developed to actually look at whole genome alignments. What do I mean by whole genome alignment? When you have a small reads or small fragments of DNA that were sequenced using Illumina or using Sanger that produces small fragments between 100 base pairs and probably 1,000 base pairs, but you have a genome that is a few million base pairs, yeah, you have to align them. Yeah, and there is a general format for alignment that is called the SAM format, SAM format. Yeah, it is very cumbersome. It has a lot of details of what each line and each column represents because it's just a tabular format, it's just a table. Yeah, but it all has a lot of meaning. And SAMTools was created just to handle that table in the most efficient way possible. Just as the sequences in FASTA files, SAMTools was created to handle the SAM format. You can Google it. You can say SAM format, and you will get 1,000 different results. Usually the top first results are the ones that are the most informative. It will show you what's the format about, how are the headers formed, what each record means, etc. It has a very complex composition to it. But yeah, this was generated for this. We can actually play a little bit with this. Let's do, if we have time right now, or do you prefer to do it after the coffee? A very quick exercise. Well, maybe half an hour. After coffee, right? I don't think anybody wants to leave early today, so.